People of different ages, nationalities, and species play ping pong. People even kill over it. But how many people know that rotational mechanics plays an important part in every ping pong match? Rotational mechanics is the measurements and study of objects spinning or rotating. In ping pong, when the ball is spun, it is spinning on an internal axis in one direction, either clockwise or counterclockwise. This is done by swiping the paddle against the ball, causing it to spin either clockwise or counterclockwise along its internal axis. When the ball is spun on the table like this, it's an easy demonstration to show that the ball spins in one direction. Angular displacement is an important measurement in rotational mechanics. It is represented by the equation change in theta equals s over r, where s equals arc length and r equals radius. In the cross-section of a ping pong ball shown here, s and r are represented by the lines, and theta is represented by the angle created by a point on the outside of the ping pong ball spinning after it is spun by the ping pong paddle. Angular displacement is important for measuring how far a point on the ping pong ball travels when it spins. This can be used to find even more complicated parts of spinning and rotational mechanics, such as angular velocity and angular acceleration. When the ball spins counterclockwise, theta is positive, and when it spins clockwise, theta is negative. In rotational mechanics, there are two major points about velocity. First is angular velocity, and the second is tangential velocity. Angular velocity measures the angle over time, while tangential velocity measures the distance over time. Angular velocity is represented by lowercase omega, and the equation lowercase omega equals change in theta over time, where theta is in radians. Tangential velocity measures distance over time, and is the linear velocity the object would have if it flew off tangent to the circular path from the ball. It is represented by the equation v subscript t equals radius times angular velocity. In the diagram shown here, tangential velocity is represented by the line spinning straight off of the circle. The final part of rotational kinematics is angular acceleration. It is represented by the equation lowercase alpha equals change in lowercase omega over time, otherwise known as angular acceleration equals change in angular velocity over time. Much like tangential velocity, the equation for tangential acceleration is a subscript t equals radius times lowercase alpha. In ping pong, angular acceleration manifests itself when the ball is spinning towards the other opponent's side of the table. As the ball's velocity slows down or speeds up, either later in the path or earlier, the acceleration is changing. Overall, rotational kinematics play into ping pong through the type of shot you hit. Whether it be topspin, a cut shot, or a side spin, rotational kinematics determine where the ball will hit, how it will travel, and how well the opponent will be able to return it. The more angular displacement a ball spinning has, the larger its angular velocity will be, making it even more difficult for the opponent to return the shot, or to predict where the shot will land once it reaches their side.